the correlation coefficient is easy to calculate once you have the notion of converting things to standard units. What you do to find the correlation coefficient between x and y is you convert x to standard units, you convert y to standard units, and you take the average value of their product. Okay? You need to keep the pairing right. We're talking about, if we're looking at verbal GMAT and quantitative GMAT, the value of verbal GMAT in standard units that we multiply times a given value of quantitative GMAT in standard units has to be for the same student, right? We got to keep the pairing, right? We're multiplying two measurements for the same individuals. Got to keep the order the same. All right, so here's an example. We have a list of weights of people in pounds and their heights in inches. So this is one person who was 71 inches tall and weighed 216 pounds. Here's a scatter plot for these fake data. Oops. Starts down here. What would you guess the correlation coefficient to be? There are not very many points there, but 0.6, 0.7, somewhere around there. Yeah. Positive, clearly positive. Yeah. All right. Okay, so the point of averages is 64.4 inches, 182.5 pounds. The SD of the heights is 7.17 inches. The SD of the weights is 49.06 pounds. So how do we calculate the correlation coefficient? We have these two lists, 71, 72, 61, et cetera, are the heights. 216, 264, 186, et cetera, are the weights. So now we've got the heights here, the weights here for the same individual. So the 71 inches is the same person who weighed 216 pounds. Okay? We're keeping individuals together. We need to convert the height into standard units. Well, how did we get 0.921 from 71? Right? We took 71, subtracted the mean, which is 64.4, and divided by the standard deviation, which is 7.17. Okay, so that's 0.921. To convert 216 to standard units, we take 216, subtract 182.5, that's the mean of the weights, and then divide by the standard deviation of the weights, which was 49.06 pounds. So if we do that, we get 0.683. Now, just as a sanity check, 71 is above 64.4. It's above average. So this ought to be a positive value, which it is. Similarly, 216 is above average. It's above 182.5. So this ought to be a positive value, which it is. Now what we do is we take this value of standard units times that value in standard units to get the product. We do that for all the measurements. We now average these products. Okay, we add up these numbers and divide by how many there are. Are there 10 of them? Yes. Okay. All right. So 0.9 is correlation coefficient, according to this. So that's rather bigger than I would have guessed from looking at the data. Okay. So, yep. Yes.
I mean, could that be because like the lack of points is kind of hard to predict?
I think that probably it's this point way down here is having a pretty strong influence on the correlation coefficient. Yeah. We can try reloading the page. Yes. Send my personal information all over the web. There. At least back to my server. Okay, there's a point over here. Right? There's points down there. This definitely looks weaker. Right? At any rate, the same kind of calculation going on. In this case, the correlation coefficient is a little under a half. Okay. So practice. Reload the page, get some practice. All right. Now, when you convert a list, yes, question. We're calculating, well, in this example, sort of what's originally given are the values in original units. And then in order to convert to SU, what we would do is we'd find the mean of this list, the standard deviation of this list. To convert 199 to standard units, we would take 199 minus the mean of the list divided by the standard deviation of the list. And so the mean of the list is, in this case, being told to you that the mean of the weights is 195.1 and the standard deviation of the weights is 45.99. So if we take 199, subtract 195.1, divide by 45.99, we get 0.085.